Today I'll be solving question 14C from the 2018 HSC Maths Extension 2 exam. So we've got IN integral is equal to from minus 3 to 0 of x to the n times root x plus 3 dx. So we've got this reduction formula we want to prove of IN equals negative 6n over 3 plus 2n of IN minus 1. Alright, so IN, we got this integral, and since we have reduction formula here and we have some two things that we're multiplying together here, product of two different expressions, we can use integration by parts here. And what I'll use is I'll let u equal to x to the n and v dash equals square root of x plus 3. Okay. Now if I take the derivative of u, we have nx to the n minus 1 with power rule. Okay, just for make it a bit more clear, I'll write it as x plus 3 to the half. To find the antiderivative of v, you can add the power by 1, and we also have a 2 over 3 here. This is the same as 2 over 3 x plus 3 square root of x plus 3 here. Now IN we can write as integral, you write uv from 0 to minus 3 minus the integral of v du. So we have vu dash dx. Okay, so we have x to the n for u and 2 over 3 x plus 3 x square root x plus 3 for v from 0 to minus 3 minus minus 3 to 0 of v du. Okay, now we have 2 over 3 times 0 to the n of 0 plus 3 root 3 minus 2 over 3 negative 3 to the power of n minus 3 plus 0, 3, square root minus 3 plus 3 minus the integral of minus 3 to 0 2 over 3 x plus 3 root 3 here times nx to the n minus 1 dx. Okay, now we have a 0 here and some zeros here, so both expressions are 0 here, so we just have minus of minus 3 to 0 2 over 3 x plus 3, and we have this expression now. Okay, now we can just take out the factor of 2 over minus 2 over 3 n here, and we have integral of x plus 3 root x plus 3 times x to the n minus 1 dx. Alright, and now, okay, and this we can write as minus 2 over 3 to the n of n minus 3 to 0 of, we have root x plus 3 here, and we can write x to the n plus 3 x to the n minus 1 dx. And this is equal, we can add up two different integrals of, we can add up the integral of x to the n, x root x plus 3, and 3 of minus 3, 0, x to the n minus 1 x plus 3 dx. Now we can notice this is equal to IN, and this is equal to IN minus 1. So we can now find IN in terms of IN minus 1. So we're actually writing the integral IN in terms of itself. So we have minus 2 over 3n IN plus 3 IN minus 1. This is equal to IN. Okay, now we can multiply both sides by 3, so 3IN is equal to minus 2n IN and minus 6IN minus 1, minus 6n IN minus 1. Now we have 2n plus 3 in equals minus 6n in minus 1. So finally we have in is equal to minus 6n in minus 1 over 2n plus 3. Just check that. So we have minus 6n over 3 plus 2n of in minus 1, so that's correct. Now next question is to find the value of I2. Hopefully we can use our reduction formula to find what I2 is. Okay, so again I'll just rewrite. So in was this integral, and we found this is equal to minus 6n over 2n plus 3 in minus 1. Okay, so what we can do is find I2 in terms of I1 and I1 in terms of I0, and all we have to do is now find what I0 is. So I0 is just putting n as 0, so x to the 0 is 1, so we just have root x plus 3 dx. This is equal to x plus 3 to 3 over 2 and 2 over 3 here. You have 0 and minus 3 here. Okay, this is equal to 2 over 3 times 3 to the 3 over 2 minus 2 over 3 of minus 3 plus 3 to the power of this. And now we have 2 over 3 times 3 root 3 minus, and this is just 0. This is equal to 2 root 3 here. And now I1, we can use the formula. So we have minus 6 times 1 over 2 times 1 plus 3 times I0, which is equal to minus 6 over 5 I0, which is minus 6 over 5 times 2 root 3, so that is minus 12 over 5 root 3 here. And finally I2, we use the formula in terms of I1. We have minus 6 times 2 over 2 times 2 plus 3 times I1, which is minus 12 over 7 I1, minus 12 over 7 minus 12 over 5 root 3, which is 144 over 35 root 3. Okay, and this is our final answer for this integral. Okay, so that we use so what we did first was use integration by parts to find the reduction formula over here, to find in terms of in minus 1, and just now to find I2, all we have to do is first find I0. So I0 is, we found, was equal to 2 root 3 here. And now applying the reduction formula twice, we can now build our way up to I2, which is now equal to 144 over 35 root 3. Okay, so that's all I have for this video. Thanks for watching, and I'll see you next time.